The distributive property tells us that if I have a number multiplied by a group, I can distribute that multiplication to every term in the group so that a times the group x plus y is equal to a times x plus a times y. So I like to show that multiplication by marking the text, and it helps me to keep track when I'm solving problems. So I'm going to use that to demonstrate how to apply the distributive property in each of the three problems below. In problem A, we're going to multiply the term negative 5x squared by every term inside of the group. This gives me negative 5x squared times x cubed plus negative 5x squared times negative 2x squared plus negative 5x squared times 1. I go ahead and simplify. Negative 5x squared times x to the power of 3 can be thought of as negative 5x times x times x times x times x. These 3 x's come from x cubed, and these 2 x's come from x squared. When I'm done multiplying that out, I get the expression negative 5x to the power of 5 because there's 5 x's being multiplied in a row. Using that same logic, I do negative 5x squared times negative 2x squared. Negative 5 times negative 2 is positive 10. X squared times x squared is x to the power 4. Excuse me. Plus, I'll bring this down here too. Plus negative 5x squared times 1, which is just negative 5x squared. Now, when I have plus a negative number, that's the same as writing subtraction. So down here in my final step, I'm going to simplify this as negative 5x squared or minus 5x squared. I go through and check the exponents of each of these terms. The first term is negative 5x to the power of 5. The second term is 10x to the power of 4. And the third term is negative 5x squared. None of those have the exact same variable with the exact same exponents, so I cannot further simplify this, and this is my answer. I'm going to bring this work down so that I have room to show part B. For part B, notice that I do not have a grouping symbol. The distributive property works in two different directions. I can start with a product of a number and a sum, or I can reverse the distributive property and identify exactly which items and which, which terms have been multiplied by each term that would have originally been in the group. So what I want to do in part B is reverse the distributive property. I want to identify my common factor that's in both terms, and I want to pull it outside of the group using division. So let's talk about the different terms that compose part B. 21 is the same as 3 times 7. Those are prime factors, and I'm just breaking it down with multiplication a little bit. My x to the power of 5 could be written as x times x times x times x times x. Similarly, I'm going to break down my 14x squared. 14 could be written as 2 times 7. Those are also prime factors, and it lets me see my common factor of 7, so that's what my goal is here. So I'm going to rewrite minus 14x squared as 2 times 7 times x times x. Looking at these, I'm looking for factors that each term has in common. Both terms contain the number 7, and both terms contain 2 x's. So I'm going to use division, and I'm going to divide each of these terms by 7x squared. If I divide out my 7x squared from my first term, I'm left with 3x to the power of 3. And if I divide out 7x squared from my second term, I'm left with -2. So in this way, I can use the distributive property to go in reverse and take my sum and divide out a common factor. So this solution has taken the expression in part B and rewritten it using the distributive property. Except since I didn't start with grouping symbols, I knew I needed to end with grouping symbols. Last but not least, the distributive property can be used multiple times if I have more than one term in my factor. So part C, I'm going to apply the distributive property first. By considering this entire group, I'm going to apply the distributive property to multiply it by 2x, and then I'll multiply the entire group by 5. This gives me the expression 3x plus 1 times 2x plus 3x plus 1 times -5. It's important to note that the subtraction of 5 can be written as the addition of a negative number. So that's why I wrote a plus here in the middle, but I kept my negative sign with the -5. That helps me make sure that I don't make any mistakes when I am calculating with my signs. Now I'm going to apply the distributive property again to each group. 2x will get distributed to the 3x and to the 1. -5 will get distributed to the 3x and to the 1. My new simplified expression, well, it won't quite be simplified, but my new distributed expression is 3x times 2x. 3 times 2 is 6. X times x is x squared. So 6x squared plus 2x times 1 is 2x. Plus 3x times -5 is -15x. I could have just written that as subtraction, but I'd already written the plus, and I still need to add them together, so I'm not done anyway. Plus 1 times -5. To write this simply, I'm going to combine like terms. Notice both of these terms here contain just the variable x. I can combine those into a single term. So I get 6x squared. 2x minus 15x is -13x. So minus 13x. -5 times 1 is -5. When I add -5, it's the same as writing subtract 5. So this is my simplified expression after applying the distributive property.